Imagine the most mysterious and powerful objects in the universe, black holes, invisible titans whose gravity is so intense that not even light can escape. Now, picture two of these cosmic giants on a collision course, locked in an inevitable spiral toward one another. What happens when they finally meet? Black holes can form from the remnants of massive stars, collapsing under their own weight after burning through their fuel. These colossal forces of nature can wander the universe alone, but sometimes, by chance or design, two black holes come close enough to begin orbiting each other. This marks the beginning of one of the most violent and fascinating events in the cosmos, a black hole merger. As these black holes orbit in vast, slow circles, they gradually lose energy. But they don't lose it alone. The space around them is filled with dust, gas, and sometimes even planets or stars. Everything that falls near the black holes either gets swallowed or escapes just in time, adding to the cosmic chaos. Bit by bit, these interactions sap the energy from the system, causing the black holes to draw closer together. What once started as a distant dance slowly becomes an unstoppable death spiral. And this is where things get truly extraordinary. As the black holes get closer, they don't just disturb nearby matter, they disturb space and time itself. Gravitational waves, ripples in the very fabric of the universe, begin to form. These waves are incredibly weak at first, nearly impossible to detect. But as the black holes approach their final moments, the energy intensifies. The gravitational waves start to carry away enormous amounts of energy, pulling the black holes even closer. But what really happens when they collide? What cosmic secrets are locked inside this ultimate showdown? We'll explore that in the next section. Picture this, two massive black holes, each tens of times the mass of our Sun, caught in a gravitational ballet. At first, they move in wide, slow orbits, like dancers keeping their distance. But with every turn, they lose just a bit of energy, drawing imperceptibly closer. This is no ordinary dance, it's a spiral of destruction, driven by forces that warp space and time itself. At this stage, the space between the black holes is filled with debris, gas, dust, and sometimes even entire stars that get too close. These objects are doomed the moment they enter the black hole's gravitational influence. Some are pulled in, swallowed whole, never to be seen again. Others whip past, their velocities altered, leaving the system drained of a little more energy. Slowly but surely, this loss of energy brings the two black holes closer. What was once a wide, lazy orbit tightens as they fall toward one another. But the most fascinating part? As they get closer, the very fabric of the universe begins to tremble. Black holes, with their unimaginable mass, distort space-time. This distortion isn't just a local phenomenon, it sends ripples, known as gravitational waves, out into the cosmos. These waves are like the ripples you'd see in a pond if you tossed two stones in and watched as their waves collided. The difference here is that these ripples travel across the universe, carrying with them the story of this cosmic encounter. However, there's a catch. At this stage, gravitational waves are incredibly weak. They don't yet have the power to cause a full collapse. In fact, it's a mystery how black holes manage to close the final gap between them. Known as the final parsec problem, it highlights a gap in our understanding. Simulations show that black holes can get to within about 1 parsec, roughly 3.26 light-years, of each other, but at that point, the forces at play become too weak to finish the job. We don't know exactly what happens next. But we do know that when they get close enough, the gravitational waves take over, and suddenly everything changes. It's as if the universe itself speeds up the process, pushing them together in a last, violent embrace. At this point, they're not just orbiting each other, they're hurtling toward a collision that will rock the very foundations of the cosmos. Can you imagine what it must be like in those final moments, as space-time warps and twists, bending to the will of these cosmic titans? That's the mystery we'll uncover in the next part, where the real drama of the black hole merger begins. Now, we arrive at one of the most puzzling and exciting mysteries in astrophysics, the final parsec problem. It's the ultimate cosmic puzzle that even the sharpest minds in science have yet to fully unravel. So far, we've seen how two black holes, after losing energy to their environment and gravitational waves, slowly spiral toward each other. But when they get to within about 1 parsec, roughly 3.26 light-years apart, they hit a wall. And not a literal wall, but a point where the forces that have been driving their merger seem to lose their punch. Here's the problem: at this distance, gravitational waves alone are far too weak to pull the black holes any closer. At the same time, there's just not enough stuff, gas, dust, stars, left around the black holes to continue siphoning off their energy. It's as if the dance that brought them together suddenly loses its rhythm, and they're stuck in limbo. Scientists call this the final parsec problem because we're left wondering how, if at all, black holes can close this last bit of distance and finally merge. Astrophysicists have proposed several theories to explain this gap in our understanding. Some suggest that hidden pockets of matter or dense star clusters might provide the gravitational nudge needed to bridge that final distance. Others hypothesize that complex interactions with other black holes or massive objects in the area could help resolve the impasse. There's even speculation that exotic forms of matter or new physics might be at play, ideas that challenge our current understanding of the universe. But the truth is, no one knows for sure how black holes manage to overcome this final hurdle. The fact that black hole mergers have been detected, however, means that somehow, the universe has found a way to make it happen. And while the specifics remain elusive, one thing is clear: when the black holes do close this final gap, the result is nothing short of spectacular. Once they're within that last fraction of a parsec, the weak gravitational waves that have been rippling through the cosmos suddenly become shock waves of unimaginable power. In those final moments, as the black holes spiral into one another, they begin to twist and warp spacetime more violently than ever. It's a chaotic, unstoppable rush toward collision, where the fabric of the universe itself bends and contorts. But what happens next? How do these cosmic giants actually merge, and what strange phenomena occur in those final milliseconds? That's where the real mystery begins, where the known laws of physics start to blur, and the universe reveals its most hidden secrets. Let's dive into the heart of the collision in the next part, where the two black holes meet and the cosmos is forever changed. Now, we arrive at the climax, the moment when two of the universe's most powerful forces collide in a cosmic event so extreme, it's beyond anything we can directly observe. As the two black holes close in on each other, something extraordinary happens. Their immense gravity begins to distort not just their surroundings, but each other. These black holes, which don't have solid surfaces, begin to stretch and elongate. Their event horizons, the boundaries where not even light can escape, start to deform, reaching out toward one another like two cosmic giants extending their arms. At first, these distortions are small, almost imperceptible. But as they approach within fractions of a second from their final collision, space and time itself begin to twist more violently. Picture this: the very fabric of the universe stretching and bending under the intense gravitational pull, as if reality is being warped by their immense power. In these final moments, something strange and beautiful happens. The two event horizons begin to form a connection. Simulations show that a tiny tendril of spacetime extends from each black hole, reaching out across the gap between them. These tendrils meet, creating a bridge, a tunnel of sorts, linking the two black holes together. It's as if the universe is trying to pull them into one final, unified form. As this bridge forms, it widens almost instantaneously. The event horizons of the two black holes, once distinct and separate, begin to merge. Like two soap bubbles colliding and joining into one, the black hole's boundaries meld together, creating a single, larger black hole. This merger happens incredibly fast, in mere milliseconds, but the effects are profound. In that brief moment, the two black holes become one, and all the mass, energy, and information they once contained is combined into a single, far more massive entity. But this is where the mysteries of black holes deepen. Inside this new black hole, at its core, lies the singularity, the point where our understanding of physics breaks down entirely. The singularities of the two original black holes also merge, but what happens in this process is anyone's guess. At the singularity, density becomes infinite, and the known laws of space and time cease to function as we understand them. We can't see into the singularity, and even our best theories can't fully explain what happens there. However, one thing we do know is that the resulting black hole is less massive than the sum of its parts. How? When the two black holes merge, a portion of their combined mass, about 5%, is converted into pure energy, radiated away in the form of gravitational waves. It's an astonishing fact. In a fraction of a second, these waves carry away the energy equivalent of several suns. This energy release is so immense that, for a brief moment, the power output exceeds that of all the stars in the universe combined. And yet, despite this cataclysmic event, it happens in complete silence, invisible to the human eye. The universe itself absorbs the impact, leaving only the faintest ripples, gravitational waves, traversing the vastness of space. The collision and merger of black holes is a truly awe-inspiring phenomenon, one that reshapes the cosmos on a fundamental level. But what's even more remarkable is that these gravitational waves, although nearly impossible to detect, have become the key to understanding these cosmic events. In the next part, we'll explore what this discovery means for science and how it has opened an entirely new chapter in our exploration of the universe. When the two black holes finally merge, the newly formed black hole settles into its final shape, emitting a last, intense burst of gravitational waves. These waves ripple outward, traveling across the universe at the speed of light. Though we can't see or hear them, we can detect these faint echoes of the cosmic collision. In 2016, scientists made history when they detected gravitational waves for the first time, confirming a key prediction of Einstein's theory of general relativity. This discovery marked the dawn of a new era in astrophysics. Gravitational waves allow us to listen to the universe in a way that was never possible before. Through them, we can study black holes, neutron stars, and other extreme phenomena that were once invisible to us. These waves carry information about events billions of years in the past, offering a glimpse into the most violent and mysterious processes in the cosmos. Every new detection reveals a little more about the workings of the universe, from how galaxies form to the nature of space-time itself. Yet, despite this progress, many questions remain unanswered. What happens inside the singularity, where physics as we know it breaks down? How do black holes overcome the final parsec problem? And what new mysteries will gravitational waves uncover in the future? As we continue to push the boundaries of science, black hole mergers remind us of the vast, untapped potential of the universe. These collisions, happening in silence and darkness, leave behind ripples that we are only beginning to understand. They challenge us to think beyond what we know and to explore what lies at the edge of our knowledge.